Okay, so now the lesson today is going to be about psychobiology or biopsychology. It's in essence the biology of behavior. And there's one thing that I want you to understand. There's a strong push on the field at this moment. There's a strong push to incorporate biological components into our study of the mind and behavior. So much that there's a saying, you have to remember this one. Everything psychological is simultaneously biological. Right now, the interest in the mind and the interest in behavior has to be coupled, or should, or must be coupled with biological components. So we emphasize the study of the neuron and we start to emphasize the study of the brain. Let's want to keep it broad. The study of the neuron, in essence, could be broken down into the cells. When you see your hand, touch your hand. Firm. Do you feel the firmness in this? Well, if you were to see it at a microscopical level, we're nothing but a bunch of cells connected. A bunch of cells connected, which allows to this kind of sensation. If you see it at the microscopical level, but in the brain, you have your neurons. The neuron is the major cell in the brain. Neurons allow for communication to happen, and the brain, pretty much from the moment that you're in about the 6th week of prenatal development, starts to send electrical activities, activates, and it will remain active until the day that you die. Even when you're sleeping, your brain is going. So within the neuron, the structures that matter more are your axon, your dendrites, and your synapse. Your dendrites are the ones, little branches that receive information. Your axon is the long fiber that sends out information. And your synapse are the gap between neurons. There's a gap in the middle where information is floating, so it can be picked up. Lastly, there is a fatty coating that protects the fiber of the axon, and you call that the myelin sheath. That one is responsible for protecting the axon, so you can send out information efficiently, and it also allows for that kind of speed of thought. When you have crossing thoughts through your mind, if you're taking a test and you know the answer right away, even before you finish reading the question, you already know the answer, your myelin sheath is allowing for that kind of speed of response. That being said, let's talk broadly about the brain. So, the brain. The main neurons are spread out through the cortex. The cerebral cortex has trillions of neurons. And the cortex can be divided in different areas, but let's think about this first in terms of halves. You have your half, your left half, and your right half. Your right half is responsible for the left side movements. Your left half of the brain is responsible for the right side movements. They tend to work like that. But in the middle, if you were to open a brain like that, you see a bundle of fibers, which you call the corpus callosum. Allows for the two halves of the brain to work collectively as one. Basic structures of the brain that matter quite a bit are coming within the cortex. Your prefrontal cortex, remember this, is the one that takes the longest to mature. It will not finish maturing until you're 24, 25 years of age, and is the one that allows you to have reasoning, judgment. The reason why most people are entirely mature until 25 years of age is because they have full maturation of the prefrontal cortex. Now, in the back of the brain, you have two structures that matter quite a bit. You have your brainstem and your cerebellum. Those two are basic for their own behaviors. The brainstem allows the brain to properly do its automatic survival functions, like breathing, blinking. Imagine if you had to consciously focus every time you had to breathe. Your brain wouldn't be able to do anything. So you have a part that is specially devoted for that. While your cerebellum takes care of voluntary movement, the movement that you have. Imagine if you had to consciously focus every time that you had to take a step. You wouldn't be able to do anything, right? That being said, the last part that I want to emphasize And I do need to emphasize that part is the limbic system. It's a collection of structures deep within your brain. Within the limbic system, there are two parts that matter a lot, at least for my class. Hippocampus, that's one. Your hippocampus is responsible for the production of memories. Most of us, and I'm including you in this, whoever is watching, if you were to think of where is your oldest memory, most likely your oldest memory was from the time that you were 5 or 6 years of age. If I'm right, don't freak out, I'm not reading your mind. If I'm right, it's because your hippocampus finishes maturation by 5 or 6 years of age, allowing your brain to start to encode memories. Everything psychological is simultaneously biological. Lastly, your amygdala. I will emphasize the amygdala. The amygdala is responsible for emotions. Little, sharp part on the limbic system, well cushioned by your cortex, that is responsible for your emotions. You will never stop having emotions. And there will be moments in your life when emotions will magnify. Have you noticed how 2-year-olds, if they find something funny, they tend to laugh and laugh and laugh and laugh hysterically? When you're an adolescent, have you noticed how if you fall in love, you tend to fall in love hard? Have you noticed how elders sometimes tend to be a little bit impulsive with their decisions? If they want to say something mean, they're just going to say it. That is your amygdala at work. Everything psychological is simultaneously biological. Remember those parts. Those are the main ones. And of course, it extends and is much more complex than this. But for a brief introduction, we're going to use those as the foundation for most of what we will learn in this course. All right? See you then.